Hi, in this video we will discuss about important topic in electromagnetic theory, that is nothing but Maxwell's equations. These Maxwell's equations are four. These four equations are derived with the help of the four laws. They are Gauss law for electricity, Gauss law for magnetism, and third one is Ampere's law, fourth one is Faraday's law. By using these four laws, we can derive Maxwell's equations. First of all, Gauss law for electricity or else Gauss law for electric field is like this. It states that electric flux through a closed surface is equal to charge enclosed by that volume. See the statement, electric flux through closed surface is equal to charge enclosed by that volume. Here flux equal to charge enclosed by that volume, that is psi equal to q enclosed. Here it relates flux and charge. These are two key terms. Another key terms are closed surface and volume. If line is closed, that becomes what? Surface. If surface is closed, that becomes what? Volume. Here closed surface relates to what? Volume. That's why here we mentioned that closed surface by that volume. Psi equal to q enclosed, or else total flux through a closed surface. We can write this as total flux through a closed surface equal to the charge enclosed by that volume. Now let us represent flux in terms of the flux density, charge in terms of the charge density. We know that current density is nothing but what? Current per unit surface area. Current per unit surface area. That means here this current is passing through this surface area. As this surface area changes, that means change in surface area leads to change in the current passing through that area. Then if you apply, or else if you write expression for dI, you will get what? dI equal to j into s. Basically it is j dot ds. Both are vectors, but this one is scalar. A scalar can be represented as what? Dot product of two vectors. Just similar to this, that is I equal to integral j dot ds. That means current is surface integral of current density. By applying this similarity, we can write flux in terms of the flux density. That means as current is equal to the surface integral of the current density, flux is equal to the surface integral of the flux density. That is electric flux density is represented by d. Then we can have psi equal to integral d dot ds. Means I can write psi here as what? Integral d dot ds. But what type of surface it is? Closed surface. Here we have surface integral, that is open surface integral. We need to close this one. That means in order to represent closed surface, we have to take closed surface integral. Similarly, here current is equal to what? Surface integral of the current density. That means integral of current density gives current. Here integral of flux density gives flux. Similarly, integral of charge density gives charge. What type of charge? Charge enclosed by that volume, means it is volume charge. Due to that volume charge, there exists a charge density. The charge density is known as what? Volume charge density, because charge is in the volume. So that's why you have a volume charge. That means integral of the charge density equal to the charge. By substituting these two, that means q equal to what? Integral rho v dv and psi equal to integral d dot ds. So what we applied here? A basic definition. That is what? Integral of density parameter gives that parameter. That means integral of current density, current. Integral of charge density gives charge. Integral of flux density gives what? Flux. Now we have this relation. What I said, a closed line becomes surface and a closed surface becomes what? Volume. So here it is closed surface, this one is volume. In order to get the relation, we need to convert closed surface into volume integral, because a closed surface becomes the volume. By applying a theorem called Gauss divergence theorem, apply Gauss divergence theorem, 2 LHS. Gauss divergence theorem, 2 LHS. Apply Gauss divergence theorem. Apply Gauss divergence theorem. You will get here closed surface integral becomes what? Volume integral. Theorem name is divergence. When you apply Gauss divergence theorem, this vector becomes divergence of that vector. That means basically Gauss divergence theorem is used to convert closed surface integral into volume integral. This closed surface integral becomes volume integral and vector becomes the divergence of that vector. So now we have what? Integral rho v dv. Finally, here you can see integrals are equal, therefore integrands must be equal, that is del dot d equal to rho v. This equation is known as one of the Maxwell equation, or else we can call this as first Maxwell equation because we derived firstly. So that's why it is Maxwell's first equation. What is that? Del dot d equal to rho v. Now we will see another Maxwell equation that can be derived with the help of the Gauss law for magnetism. Here this Gauss law for electricity tells about electric flux. This Gauss law tells about what? Magnetic flux. So that is magnetic flux through a closed surface. There electric flux through a closed surface. Here magnetic flux through a closed surface is equal to, magnetic flux is represented by pi is equal to 0. Here flux equal to charge. Why? Because we have electric field lines due to what? Charge, that is positive charge to negative charge. That means electric field lines are emerging at positive charge and terminating at a negative charge like this. So these are what? Electric field lines. Electric field lines are called as what? Electric flux. That means electric fields due to what? Positive charge or negative charge. That means there exists positive charge as well as negative charge. So due to positive charge we have a field line like this. Due to negative charge, that is a field terminating at the negative charge. But in case of the magnet, there is no monopole like positive or negative. We have, if you take any magnet that is consisting of what? Either it is small or large, it is consisting of what? North and south poles. There is a non-existence of magnetic monopole. Whereas in case of the electric charge, there exists separate positive charge and negative charge. There is a possibility of monopole in case of the electric field. But in case of the magnetic field, in case of the magnet, there is no such monopole. Non-existence of monopole leads to what? Pi equal to 0. I will explain this one later. So here what I said, flux equal to what? Surface integral of the flux density. As it is electric flux, it is represented in terms of the electric flux density. That means surface integral of electric flux density equal to what? Electric flux. Apply the similarity. Here it is what? Magnetic flux. This magnetic flux can be represented in terms of the magnetic flux density. That means surface integral of magnetic flux density is equal to what? 0. That means the surface integral of magnetic flux density equal to what? Magnetic flux. Just as psi equal to integral d dot ds, pi can be written as what? B dot ds. But this flux is what? Magnetic flux through a closed surface. As it is closed surface, we need to take what? Closed surface integral. I said that a line, closed line becomes surface. Closed surface becomes what? Volume. That means we can convert this closed surface integral into volume integral by applying Gauss divergence theorem. Apply Gauss divergence theorem to this one. This closed surface integral becomes what? Volume integral, and this vector becomes what? Divergence of that vector, because in the divergence theorem we have divergence. So here this vector becomes what? Divergence of that vector when you apply divergence theorem. So divergence theorem is used to convert closed surface integral into volume integral. So like this. Then by applying, or else we can write this one like this, that is 0 into dv. Here integrals are equal, therefore integrands must be equal. Then we have del dot b equal to 0. If you see this equation and this equation, both are what? Divergence of electric flux density, divergence of magnetic flux density. This one equal to rho v, this one equal to 0. I said that there is a magnet. It is consisting of what? North pole and south pole. And if I cut this one into two pieces, then it is also having what? North pole and south pole, N1 and S1. And next, this one is consisting of what? N2 and S2. Magnetic field lines are closed in nature. That means here you have a field starting at this position and terminating where? At this one, like this. Like this. So north to south, north to south, like this, north to south, like this, north to south, like this. These are the field lines. Okay. So that means total flux through a closed surface becomes what? 0. So in this case it is downward, and in this case downward direction, in this case here upward. So total effect is what? 0. Okay. So due to field, due to this one, let us say some effect, and due to this one another effect. As both are in opposite direction, both will be cancelled. So then total flux equal to what? 0. These are magnetic field lines. Magnetic field lines are nothing but what? Magnetic flux. Okay. And if you see 1 and 2 are derived with the help of what? A theorem called Gauss divergence theorem. Gauss divergence theorem. Similarly, equation 3 and 4 can be derived by using another theorem. That theorem is known as Stokes theorem. That theorem is known as what? Stokes theorem. What Stokes theorem says, or else what is the application of Stokes theorem? Here divergence theorem is used to convert closed surface integral into volume integral, whereas Stokes theorem is used to convert closed line integral into surface integral. And when you apply Stokes theorem, this vector becomes curl of that vector. Del can be operated on vectors as divergence and curl. In this case divergence, in this case curl. This theorem is nothing but what? Stokes theorem. Stokes theorem is used to convert closed line integral into surface integral. I said that closed line becomes surface integral. Closed line, surface, line, closed line, surface. So let us take this one, Faraday's law. Because of this phase problem, I didn't write this statement. I will tell that statement 2 times. First time. So it says that voltage or voltage, another name is what? Electromotive force in a closed loop. Voltage or electromotive force in a closed loop is equal to decrement of, here decrement is representing with a minus sign, decrement of rate of change of magnetic flux linkage, that is lambda d lambda by dt, where this magnetic flux linkage is equal to, it is related to the flux. This magnetic flux linkage is related to the flux, that is n equal to, sorry, this lambda equal to, where lambda equal to n into pi. Okay, where n represents what? Number of turns. Let us take, let n equal to 1. In that case we can write this one as minus d by dt, minus d by dt. And we can write this as what? As n equal to 1, we can write this as d pi by dt. Already we have what? That is minus d by dt. In order to get the relation, we need to write what? Here we started what? Point form, that means simple form. Then converted this one into what? Integral form. Here it is what? Without integration or else differentiation. But here we have what? Some differentiation. Let us write all these terms in terms of the integral form or differential form. As it is in differential form, we can write this V in terms of electric field like this. V equal to integral E dot dl. Okay. I explained this relation in the topic called electric potential. Please see that video where V equal to what? Minus, since V equal to minus integral E dot dl, minus E dot dl. Here we have a line integral. Here we have what? Okay, it is differentiation. In order to get the relation, we need to convert this one in terms of the integral form. For that, let us apply here, or else let us write this term in terms of the integral, that is d by dt, means write flux in terms of the flux density. We have relation, that is flux equal to what? Integral b dot ds. But it is not, it is a simple relation, okay? That is a simple flux, not a flux through the closed surface. So that's why here we have what? Integral b dot ds. But what is the statement? I said that two times. What is the first time? I said that this one, that is voltage in a closed loop is equal to what? Decrement of rate of change of magnetic flux linkage. Voltage in a closed loop means closed line. Here we need to take what? Closed line. That closed line represents what? Closed path. So then you have this one is integral E dot dl. This one vector, this one also vector. This is scalar. A scalar can be represented as dot product of two vectors. So here I have what? Closed line integral. Here I have what? Open surface integral. Then apply what theorem we need to apply? Here there is a relationship between closed line integral and surface integral by using what? Stokes theorem. Let us apply Stokes theorem for this one. Left hand side we will get, basically here there is no negative sign. We have taken that negative sign here only. So then we have what? You will get integral E dot dl, that is closed line, equal to what? Minus d by dt integral b dot ds. Apply this one. Apply this theorem. Apply this theorem. Here you will get what? Closed line integral becomes what? Surface integral. And vector becomes what? Closed line integral becomes what? Surface integral, and vector becomes what? Curl of that vector by using which theorem? Stokes theorem. Here we will get what? I am sending this one to this one into this side. ds means dx dy or else dy dz. They are distance parameter, whereas this one is what? Time parameter. The distance parameters are also known as what? Space parameters. If I send this one into this side, that means this time is a parameter which is independent of that distance parameters. That means if you send this one into this integral term, means distance or space terms, as it is independent term, this differentiation becomes the partial differentiation. Means I can write this one dou by dou t, and here we have b minus dou b by dou t ds. Here this one becomes what? This differentiation becomes what? Partial differentiation. Why? Because it is time variable. ds can be what? Space variable. There is a independent relationship between this distance parameters and a time parameter. That's why this differentiation becomes the partial differentiation. Okay, now we have this one cancel because integrals are equal. Therefore integrands must be equal. That is what? Del cross E equal to minus dou b by dou t. This is another equation. Let us call this as equation number 3. This one is very simple. This one is very simple. That is Ampere's law. It states that the line integral of magnetic field intensity means line integral of magnetic field intensity is H. Line integral of magnetic field intensity around a closed path. Line, if it is closed one, closed line means it is closed path. That's why here instead of taking line integral, we can take closed line integral for this case according to the statement. What is the statement? The line integral of magnetic field intensity around a closed path is equal to current enclosed by that path. If you see on left hand side, it is in integral form. This one is not in integral form. In order to get the relation, or else in order to get the Maxwell equation, let us write this current in integral form. Already we have that current can be represented in terms of current density in integral form, that is given by integral j dot ds. I equal to integral j dot ds. Surface integral of current density gives the current. Surface integral of the charge density gives the charge. Surface integral of the flux density gives the flux. Surface integral of magnetic flux density gives what? Magnetic flux. Now, here closed line integral, on left hand side open surface integral on right hand side, we can convert closed line integral into surface integral by apply Stokes theorem. Why Stokes theorem is used? To convert closed line integral into surface integral. This one is closed line integral, that becomes what? A surface integral. And this vector becomes, that bar indicates vector, curl of that vector. If you apply divergence theorem, divergence of vector. If you apply Stokes theorem, curl of vector, this vector becomes curl of vector. Closed line integral becomes surface integral. Already on right hand side, what you have? A surface integral of current density, that is J dot ds. Why I am taking dot product? Because current is a scalar, but these two are vectors. This scalar can be represented as what? Dot product of two vectors. Now if you see, these surface integrals are equal, therefore integrands must be equal. That gives what? Another important equation, that is another Maxwell equation, that is del cross H equal to J. So this is fourth equation. These are the four equations derived from four laws. What are they? Gauss law for electricity and Gauss law for magnetism, Ampere's law, Faraday's law. Four equations, four laws, four constants.